everyone, this is Viji. Numpy. It is a fundamental package for scientific computing with Python. Numpy's main object is the homogeneous n-dimensional array. It could be any dimension, one-dimensional vector, two-dimensional matrix, three or n-dimensional tensor, and also homogeneous, meaning all values are of the same data type, usually integer or floating point number. The best part is it is compact, takes less memory space than a list, and brings the speed of the compiled C code to Python. Let's open the Spider IDE. Numpy is installed by default along with Anaconda package. So we can import the Numpy module as np. We are going to start with some commonly used Numpy functions and then import a CSV file to run the statistical calculations. Lists are used to store multiple items that are mutable. We have seen that before. Let's create a one-dimensional array from the list. The syntax to convert a list to an array is np.array. Let's look at the output. Print the variable array_1, the type of the variable, and the data type of the items in the variable. It is a one-dimensional array. The type is numpy.ndarray. And the data type of the item in the array is an integer of 32 bits. Let's keep the Variable Explorer tab open. We can explicitly specify which data type we want by using dtype keyword. Now, the data type is changed to float. We see decimals added after 1, 2, etc. Next, we will explore indexing. We can access the elements in the array using its index number. The indexing in Numpy starts at 0. That means use index number 1 to access the second element in the array. The value of the second element is 2. We can also assign values by indexing. Let's assign 9 to the index 1. Let's print to see the difference. Now 2 is replaced by 9. Next, let's create a two-dimensional array. The shape is 3, 4, which means 3 rows and 4 columns. We can also slice the array by index numbers. Index 1, 1 refers to the second row and the second column. The value is 6. Slicing is important. So let's look at a few more examples to get clarity around it. Index 0, colon refers to the first row and all columns. Index 1, colon includes all rows from the second row. Index 1, colon 2 is the second row and all columns before the third column. Note that the index before the colon is inclusive and the index after the colon is exclusive. Now let's look at other methods to create arrays. 2 by 2 array of zeros. 4 blocks, 3 rows and 2 columns array of ones. 3 by 3 array with ones on the diagonal and zeros elsewhere. 2 is the start value and 20 is the end value for both linspace and a range. Linspace returns evenly spaced numbers over a specified interval. 5 is the count. We see 5 evenly spaced elements, whereas 5 is the step size for a range. 4 by 2 array of random numbers between 0 and 1. We can also create a random integer array. This routine returns 3 random integers from 0 to 10. 10 is exclusive. 7, 5 and 3. Let's see some commonly used operations using two simple arrays, array_3 and array_4. Arithmetic addition, subtraction, multiplication and divisions between arrays of the same size are straightforward. We can also carry out an operation between an array and a single number or between an array of two different sizes. It is called broadcasting. We can vertically stack two arrays. We can switch the column and rows using the transpose function. We can also horizontally stack two arrays. The sort function sorts the elements in an order. We can also reshape the array. Here we are reshaping a one-dimensional array to a 3x2 array. This completes the first section. Moving to the next one, let's import the data set. Before importing, let's understand the data. It is a monthly climate data of the city Toronto. The data is downloaded from the Government of Canada website. It has 7 columns: year, month, mean temperature, extreme maximum temperature, extreme minimum temperature, total rainfall and total snowfall. It is a data of 100 years starting from 1901 to 2000. Let's copy the column's name as comments for reference purpose. The question that we would like to answer are: find maximum, minimum, range and standard deviation of monthly mean temperature. What was the highest temperature and when did it occur? What was the lowest temperature? When did it occur? What was the mean rainfall in June? What was the maximum monthly snowfall? Which month have the best bets to enjoy snow in Toronto? First thing here is to create an array E by importing the CSV dataset using the genfromtxt input function. The delimiter between the elements is comma, and also we want to skip the first row. We can see the size of the dataset by using the shape functions. It is 100 years times 12 months, 1200 rows and 7 columns. Going back to the variable explorer, we can see array E added to the list. Let's find the maximum temperature by using a max function to look at all the rows and the column of index 2, which is the mean temperature column. Minimum temperature using a min function. Range and standard deviation. Let's add units to all values. PTP, peak to peak function for range. STD function for standard deviations. Let's run it. 37.6 degrees Celsius is the total range, minimum of minus 12.1 degrees Celsius and maximum of 25.5 degrees Celsius. Too many decimals displayed for the standard deviations. Let's round it to 2 decimals. Now it looks good. Next is the highest temperature. Highest temperature can be determined by using a max function on the column of index 3, which is the extreme maximum temperature. And then use var function. It returns all the elements that meets the highest temperature condition. Let's just print the year and the month by displaying first 2 elements. The highest temperature of 40.6 degrees Celsius occurred in July 1936. We can follow the same logic to determine the lowest temperature and the occurrence, month and year. Let's run it. We can remove the scientific notations by applying the functions set_print options, assigning suppress parameter as true. The lowest temperature of minus 30 degrees Celsius occurred in January 1914 and December 1933. Next one is to calculate the mean rainfall in June. Let's select all the rows that have the number 6. 6 refers to June month. Check it. The array starts with index 5, which has a value of 6 and increased by 12 to include all June months. Now we can find the mean rainfall by including only June rows and looking at the total rainfall column. Again, too many decimals. Let's round it and add unit. Mean rainfall in June is 67.55 millimeter. The maximum snowfall is an easy one. Let's apply the a max function to the snowfall column. It is 118.4 centimeter, more than 1 meter snow everywhere in Toronto. Just a side note, I found it occurred in January 1999. Here is the related screenshot from the Weather Network site. Wow. Coming back to our next question, which months have the best bets to enjoy snow in Toronto? Let's select all the rows that had some snowfall, which means selecting all rows that are not equal to 0 snowfall. We can use a histogram to determine the frequency of snowfall in each month. What we see here is month 1 or January had snowfall in all 100 out of 100 years. The output is two arrays, one that shows frequency and another that shows the bin. Let's assign a variable hist to the first array, bin edges to the second array to separate them. Now we can print the results. Run it. Let's undock the console and maximize it. Overall, we looked at 1200 by 7 dataset, a complete 20th century climate dataset of the city of Toronto. Looking at the output, it's obvious the best bets to enjoy snow are January, February, March and December. 100% snowy winter, then nice spring, hot summer, colorful fall and then winter. Repeats. Learning is fun.